Not that sensitive. All right, so those who are not here in class, we're recording this lesson for you, and those that lost time due to a bus evacuation. All right, so we want to prove A, B, C, D is a rhombus. All right, so step one, we have to graph. This one has been graphed for you. Come on. There we go. So A here is at -3, 2. B is at -2, 6. C is at 2, 7. And D is at 1, 3. All right. Then step two, we have to figure out what is it we want to show, because we want to make sure we choose the right formulas for what we want to show. We're using the second technique, which is show all sides are congruent. If all sides are congruent, then the opposites are congruent, and it has to be a parallelogram as well as a rhombus. The formula we need, so this one's step 2, this one's step 3. Formula we need is the distance formula. Okay, so we're going to use the distance formula a whole lot. All right, so now all you have to do is find the distance for the 4 sides. Aren't you glad I wrote it down for you? So you don't have to write it down. All right, so AB, we find the distance of AB. We take the difference in the x-coordinates and square, difference in the y-coordinates and square. So -2 plus 3 squared plus 6 minus 2 squared. So -2 plus 3 is going to give you a 1 squared. 4 minus 2 gives you 4 squared. 1 squared is 1. 4 squared is 16. So that's square root of 17. We do the same thing. Now go to the next side, BC. All right, so difference in the x-coordinates, -2 minus a -2 is going to give you 4. 6 minus 7 is going to give you a -1. All right, 4 squared is going to give you a 1. 4 squared is 16, 1 squared is 1, add them together is square root of 17. Right? So we have two sides of the same. That actually is not enough to prove that this is a rhombus, because the kite has adjacent congruent sides. So one pair of adjacent congruent sides would not prove a kite, so we have to keep on going. We'll prove CD is the same length. All right, so we take the difference in the x-coordinates, 2 minus 1 squared, plus 7 minus 3 squared. 2 minus 1 gives you 1 squared. 7 minus 3 would be 4 squared, which is 1 plus 16, or the square root of 17. And on the last side, we have -3 minus 1 squared plus 2 minus 3 squared. It's going to give us -4 squared plus -1 squared. So that's going to be the square root of 16 plus 1, or the square root of 17. All right, so we found all the information we need. We can write a 2-column proof here. We always want to start off with what we're given. We're given the figure ABCD. Right? That was actually given to us. All right, we know that AB is the square root of 17, BC is the square root of 17, CD is the square root of 17, DA is the square root of 17. We know that because we use the distance formula. We know AB is congruent to CD. We know BC is congruent to DA. Segments with the same measure are congruent. So really it's not, it's just kind of explaining how you know they're congruent. That's what it means to be congruent. You have the same measure. So we know ABCD is a parallelogram because both pairs of opposite sides are congruent. We also know now ABCD is a rhombus because it's a parallelogram with 4 congruent sides is a rhombus. Every one of those sides was the square root of 17. All right? So here's our proof here for the rhombus as a 2-column proof. Now, any questions on this one? In your notes, let's also underline all sides congruent, so that when you're looking, this is the one you'd want to use if you're using that second method. All right, so we had 4 ways to prove a parallelogram, 2 for the rectangle, 2 for the rhombus. We're going to move on to square. So a square is a parallelogram with 4 congruent angles and 4 congruent sides. It's both a rectangle and a rhombus. So we have to prove it's a rectangle and a rhombus. Some formulas that might be helpful. The midpoint formula, we can show that diagonals are bisected. Right? That'll show it's a parallelogram. We can use the distance formula. We can show all sides are congruent. That'll show it's a rhombus. We can prove diagonals congruent. That'll show it's a rectangle. We can use the slope formula. We can show opposite sides are parallel. That'll show it's a parallelogram. Diagonals are perpendicular. That shows it's a rhombus. Consecutive sides are perpendicular. That shows it's a rectangle. So any of the techniques that we're going to use, we've got to show it's both a rectangle and a rhombus and a parallelogram as well. And I tend to keep things together. So I either work with the diagonals or I work with the sides. I usually find it easier just to stick with one feature. All right, so here I did the, and you have to scroll down because you can't see. Still can't see. I can't get everything in at once. Let's see, so I'm going to probably have to scroll down. Sorry, people watching this. So we'll talk about this and then I'll scroll down, everybody. All right, so here's our first method. We're going to prove it's a quadrilateral, prove the quadrilateral is a rhombus by showing we have 4 sides congruent. So in your notes, underline 4 sides congruent and rhombus, right? Can't seem to make a straight line there. All right, so we have to show it's a rhombus as part of the square proof. And we have about 5 minutes left. Can someone kind of just signal me we have 5 minutes left? All right. And then we have to prove it's a rectangle as well. And so here we'll show the diagonals are congruent. Okay. So here I just kept all with congruence, with the distance formula. I could have also just done the diagonals congruent and perpendicular. That also would have worked. All right, so here what we want to show, we have 4 congruent sides. That'll show it's a rhombus. Diagonals congruent, that'll show it's a rectangle. So basically we're just doing the distance formula 6 times. Actually though, we're only doing it twice because 4 of those, the sides are all horizontal or vertical lines. So it's actually pretty easy to find the lengths of those. So this isn't a bad technique for the fact that it's got, the sides are all parallel to the x or y axis. All right, so if we find the formula we're going to use is the distance formula and also just the difference between the x or y coordinates for those vertical and horizontal lines. So ME, which is that horizontal line on the bottom there, is just the difference in the x coordinates, right? So because those y coordinates didn't change at all. So it'd just be the difference between -2 and 4, which is going to be 6. ET is going to be the difference in the y coordinates because the x's don't change. So the difference between 2 and 8 is going to be 6 again. TS is going to be the difference in the x coordinates because the y coordinates don't change. 4 minus a -2 is the same as 4 plus 2, which is 6. And then SM is going to be the difference in the the y coordinates because the x coordinates didn't change. So the difference between 8 and 2 is going to be 6. All right, so those are our sides. All we need are the lengths of the diagonals because we've showed it's a rhombus, but we haven't shown it's a rectangle. All right, so we find the length of the 2 diagonals, SE and MT. All right, so we have the difference in the x coordinates. All right, so -2 minus 4 squared plus 8 minus 2 squared. -2 minus 4 is a -6. 8 minus 2 is +6. We square those, we get 36 plus 36, which is the square root of 72, and that simplifies to 6 square roots of 2. Right? If we do our sign chart, 1 6 comes out, 1 6 goes away, the 2 stays in the radical. All right, and we'll do the same thing with MT. So we have -2 minus 4 squared plus 2 minus 8 squared. It's going to give us a -6 squared and a +6 squared. That's going to be 72, and we already know it's 6 square roots of 2. So now we have all the information we need. We just need to do our proof. And this one I did as a 2-column proof. I'm going to scroll so I get the last step of the proof in. 8 steps, right? Then we got them all in there. All right, so if you direct your attention down to the proof, we start with our given, METS. That was given to us. That figure, those points were given to us. We know ME equals 6, ET equals 6, TS equals 6, SM equals 6. It's just the difference between the coordinates because those are horizontal and vertical lines. We have ME is congruent to ET, is congruent to TS, is congruent to SM. Congruent segments have the same measure. They're all 6. They have to be congruent. So now we've proven that METS is a parallelogram and a rhombus. Right? So it's a parallelogram because its opposite sides are congruent. It's a rhombus because all the sides are congruent. So if all the sides are congruent, the opposites are congruent. Right? So this is going to be a rectangle and a rhombus because it's a quadrilateral with all sides congruent, is both a parallelogram and a rhombus. So we prove two things at once. And you can do that if you prove all the sides are congruent. So then MT is equal to 6 square roots of 2. SE is equal to 6 square roots of 2. We use the distance formula for that. MT is congruent to SE. Congruent segments have the same measure. So now that we know they're congruent, we know it's a rectangle because a parallelogram with congruent diagonals is a rectangle. That means METS is a square because a quadrilateral that's both a rhombus and a rectangle is a square. Right? That's a basic definition for a square. So if you've proven it's a rectangle and a rhombus, you can use that reasoning in your classwork or homework, that if it's a quadrilateral that's both a rectangle and a rhombus has to be a square. Okay. So this proof requires a few more steps than some of the other proofs did because we had to prove it's a parallelogram, a rectangle, and a rhombus. We had to prove it's all three things. Any questions at all on this proof? Okay. If you forget to include, so if you leave off the rectangle portion, you've only proven it's a rhombus, not a square. Be careful. So there's probably going to be some questions on the benchmark that include things like this, and you have to make sure that you've proven all three things. All right, so here we have an alternative proof with a new square. All right, so in this proof, we have our square graphed, and our figure graph, we're proving is a square. And we're going to be showing that the diagonals bisect each other. That makes it a parallelogram. Are equal, that makes it a rectangle. And are perpendicular, that makes it a rhombus. All right, so here I could work just with the diagonals, prove three things about the diagonals, and then prove all three things. The formulas we need are the midpoint formula, the distance, and the slope. So we're using all three formulas here, but we're just using them with the diagonals. All right, so first we found the midpoint of the diagonals. All right, so we just take the difference in the x's divided by 2, difference in the y's divided by 2. All right, so if we take 4 plus a negative 3, that's the coordinates for A and C, divide by 2, and then 0 plus 1 divided by 2, 0 plus negative 1 divided by 2 gives us 1/2 negative 1/2. BD, so B is located at 0, 3, and D is at 1, negative 4. All right, so we just add 0 plus 1 divided by 2, 3 minus 4 divided by 2. So 0 plus 1 is going to give us 1/2. 3 minus 4 is going to be a negative 1/2. So notice same midpoint. That means our diagonals are bisected, and this is a parallelogram. If we prove they're congruent, then we'll prove it's a rectangle. So we just find the length. We just take the difference in the x-coordinate square, difference in the y-coordinate square. So we have 4 plus minus a negative 3, which is 4 plus 3 squared, plus 0 minus a negative, so that'd be plus 1 squared. 7 squared plus 1 squared is going to give us 49 plus 1, which is the square root of 50, which is 5 square roots of 2. Because 25 is a perfect square, right? 5 would come out, 5 goes away, the 2's left over. Same thing with BD here. So we have difference in our x-coordinates, 1 minus 0 squared plus negative 4 minus 3 squared. It's going to give us 1 squared plus negative 7 squared, which is the square root of 1 plus 49, which is 5 square roots of 2. So now they're congruent. So now we've proven it's a rectangle. But we still haven't proven it's a square. We have to show they're perpendicular. If we show they're perpendicular, we'll prove it's a rhombus. All right, so we take the slopes, all right, difference in the y's. So 0 minus a negative, that'd be 0 plus 1 over 4 minus 3, minus a negative 3, which is going to give us 1 over 7. And then for BD, we've got 3 minus a negative 4, so that'd be 3 plus 4 over 1 minus, over 0 minus 1. So then we have negative 4 minus 3 is a negative 7, and then 1 minus 0 is just 1. So that just makes that negative 7. So now you can see that our diagonals are perpendicular. That makes it a rhombus. So now we've shown it's a parallelogram from the first part, a rectangle from the second part, and a rhombus from the third part. That means it's got to be a square. So this one is a paragraph proof. ABCD is a parallelogram because the diagonals bisect each other since they share the same midpoint. You want to make sure that you're specific in your paragraph proofs. It is also a rhombus because the diagonals are perpendicular, and a rectangle because the diagonals are congruent. That symbol there means therefore. Therefore, ABCD is a square, right? Because it's a rectangle, a parallelogram, a rectangle, and a rhombus. Any questions on this proof? That's the last of my parallelogram proofs. So the other ones are just a couple triangle proofs. On the triangle proofs, we're just looking at, are they, what kind of triangle are they? Classifying them by either sides or angles. From sides, we can classify them as scalene, isosceles, or equilateral, just depending on how many sides are congruent. From the angles, all we can do is show it's a right triangle or not. You really can't show the other angles, right? On the floor, please. You're back. All right, so we want, our first step is we always want to have our model, right? So we've graphed our figure there. A is at -2, 2. B is at 4, 2. C is at 1, 6. All right, and we want to know, do they form an isosceles triangle? So we know isosceles triangles has two sides congruent. So if we want to prove it's an isosceles triangle, we're going to have to show that we have two congruent sides. Our formula is going to be the distance formula. One of our sides, though, is a parallel line, is a horizontal line, so we can just find the difference in the x-coordinates. All right, so we'll find the lengths of all our sides. So this part is part 4, excuse me. This is our work part. All right, so AB is just the difference between those x-coordinates, -2 minus 4, which is the absolute value of -6, which is 6. BC is just using the distance formula, the difference in the x-coordinate squared plus the difference in the y-coordinate squared. So 4 minus 1 squared plus 2 minus 6 squared is going to give us 3 squared plus -4 squared, which is 9 plus 16, which is square root of 25, or 5. And then we'll find the length of CA. So we'd have -2 minus 1 squared, and then plus 2 minus 6 squared. So -2 minus 1 is a -3 squared. 2 minus 6 is -4 squared, so that's going to be 9 plus 16, which is a square root of 25, which is 5. All right, since BC is congruent to CA, triangle ABC is an isosceles triangle. All right, so let's add one little sentence to that. Proof's a little short here. So a triangle is isosceles if it has at least two congruent sides. So just add that little sentence to your notes. Already filled in is what else would have to be true for the triangle to be equilateral. We'd have to know all the sides are congruent, right? And so that would also make all the angles congruent. AB here would have to be equal to 5, and it's not. We have no way of determining the angle measure other than right angle or not right angle. But if it was an equilateral triangle, then we would certainly know. 6 minutes? Okay, I'm going to stop at this point. All right, so this is the last proof I'm going to have on this podcast. And then tune into the next podcast. We'll pick up with triangles. All right, bye for now.